Sean Carroll, The Big Picture, on the Origins of Life, Meaning, and the Universe Itself. This summary delves into the groundbreaking book, The Big Picture, on the Origins of Life, Meaning, and the Universe Itself, by Sean Carroll. Embark on a journey to explore intriguing questions about our universe, the core theory, and the fundamental laws governing it. Discover how causality has been challenged and replaced by concepts of a microscopic, fundamental level and a macroscopic, emergent level. Uncover how the evolution of time and entropy shape the universe, the origins of life, and why living organisms exist. By the end, you'll gain insights into the complexities of consciousness and evolution, and why the dual nature of life remains a fascinating mystery.
The power of core theory. In the past, natural phenomena were attributed to all-powerful gods, but today, physicists have a deeper understanding of the universe. Core theory, a term coined by Nobel laureate Frank Wilczek, explains how particles interact with each other and are affected by various forces, including the Higgs field. While it has limitations, core theory covers everything that affects our daily lives, including ruling out paranormal phenomena through tools like crossing symmetry. For instance, if telekinesis were possible, there should exist a particle that can interact with matter to enable it. But since there is no evidence of such a particle even in extreme circumstances, core theory rules out telekinesis, telepathy, and levitation. Rethinking causality. The traditional belief in causality, the idea that every action has a cause and effect, is being challenged by physicists and philosophers. Aristotle's notion of a prime mover is no longer credible. Physicists disregard cause and effect in the context of conservation of momentum and the observation of patterns. Causality is no longer the fundamental principle in our understanding of things, as Laplace's example of balls on a billiard table reveals that the laws of physics, not cause and effect, determine the motion of objects. Seeing things in new ways. The abandonment of causality caused a paradigm shift in the scientific community. There are two viewpoints to understanding gases, at a fundamental, microscopic level and an emergent, macroscopic level. The microscopic level allows for precise descriptions of molecular behavior, while the emergent level allows for understanding of properties like pressure and temperature. Both perspectives have their merits, and the challenge is to choose the best one for solving a problem. The concept of emergence has been vital in our comprehension of time. The mystery of time. The laws of physics suggest that time is symmetric, but our experience of time is asymmetric due to the increase of entropy. While entropy explains why disorder is more likely than order, it doesn't account for the complexity and organization of certain systems over time. The universe's complexities. The relationship between entropy and complexity is not a straightforward one. While increased entropy usually leads to more disorder, it can, in fact, lead to more complex systems. This is because the relationship between entropy and complexity is more like a curved line rather than a linear one. At either end of the spectrum, simplicity reigns, but in the middle, complexity is at its highest. This is similar to what happens when you pour a small amount of milk into your coffee. At first, the liquids remain separate, and at the end, they are completely mixed, but in the middle, the two liquids are blending and swirling, creating a highly complex system. Like the cup of coffee, the universe was simple and homogeneous before the Big Bang occurred. And like the coffee, the universe moved towards complexity until it reached its current state, full of complex galaxies, planets, stars, and living organisms. However, the universe is moving back towards simplicity, and once the final black hole dissipates, entropy will reach its maximum, and everything will return to a state of simplicity. Although it's challenging to envision how entropy plays a role in creating complex organisms like humans and platypuses, the fact remains that complex structures in the universe are a natural result of the universe's slow and steady increase in entropy. The entropic vehicle theory. Michael Russell's entropic vehicle theory proposes that the first living organism on Earth was a way to increase the planet's entropy. Living organisms function through the hydrogenation of carbon dioxide, producing compounds with less free energy and therefore higher entropy. Russell accurately predicted the existence of underwater hydrothermal vents that helped create the right conditions for the earliest life forms. Simple life forms multiplied and mutated, and natural selection led to the development of different species and traits, including complex ones that define intelligent life. Evolution of consciousness. Humans owe their intellectual advancement to their ancestors who took their first steps on land. Bioengineer Malcolm McIver deduces that stepping onto land was a vital stage in the development of consciousness. Critical thinking became vital. However, the mystery of how our brain transforms atoms into consciousness remains. Dualists have long supported the theory of duality. Still, even the great René Descartes could not explain how the mind and body communicate. The scientific method will ultimately uncover the mysteries of consciousness.
In The Big Picture, Sean Carroll guides us through a captivating exploration of the fundamental laws and theories that shape our universe, including the core theory and its implications on paranormal phenomena. He challenges causality and addresses the role of entropy in the evolution of time, life, and the universe. We get a comprehensive understanding of the various stages of consciousness, and speculations on how it has developed throughout time. By examining the past, present, and potential future of our universe, the book ignites our curiosity about the complexities of life and its inherent mysteries, showing that scientific understanding continues to evolve.